So good morning. So today we are going to discuss corrosion control. So we have discussed what is corrosion, how corrosion occurs, what are the factors affecting corrosion. So let us see how to control corrosion. Controlling corrosion is the biggest task for an entire. It's not only a Indian's problem or one particular state or region or religion problem. It's a universal problem. So any country you name, controlling corrosion is the biggest problem. So India alone spends hundreds of crores to control corrosion. So how to prevent corrosion? So the corrosion prevention starts from your gate, your window panes. Then how do you prevent the corrosion of your gate or window panes? You're going to paint it. So simple preventing technique is by painting it, isn't it? By painting, you're going to prevent corrosion. So similarly, so industry also loss occurs only because of industries. So how to prevent this corrosion in industry? So let us see. So there are various techniques. That is, one of the technique is by technique is galvanization. That is metallic coatings. You have organic coatings. By doing metallic coating, again metallic coating is divided into organic coatings, inorganic coatings. Okay, so by doing anodizing, again we have inorganic coating, that is phosphating, again cathodic protection, anodic protection, anodizing. So let us discuss these things one by one. To start with, so corrosion control, as I told you, so it is done by done by your metal coating, metallic coating, anodizing, or cathodic protection. So coating one metal on the surface of another metal is called as metallic coating. So metallic coating, you have two types of metallic coating. One is anodic coating, other one is cathodic coating. So anodic coating is coating one metal on the surface of coating anodic metal, coating anodic metal, which is coating a metal which is anodic to the base metal is called as anodic coating. So cathodic coating, nothing but coating a metal which is cathodic to the base metal is called as cathodic coating. So what is the base metal? Metal to be protected from corrosion is called as base metal. So this metal should be coated, or this metal should be protected from corrosion. This is called as base metal. Okay, so anodizing, cathodic protection, let us discuss one by one. We have anodic coating. So anodic coating is nothing but coating a metal which is anodic to the base metal. The best example for anodic coating is galvanization. So what is galvanization? So coating a metal, coating zinc on the surface of anode or cathode, coating zinc on surface of iron or steel alloys is called as galvanization. You're going to take iron sheet, dip it in organic solvent in order to remove the dust, oil, grease, then pass in the rollers, then dip it in dilute sulfuric acid in order to remove the rust, then dip it in zinc chloride, molten zinc, and add ammonium chloride as the accelerator and dry it to get and then dip it in molten zinc and pass in the in between two rollers in order to get uniform uniform thickness of the zinc deposition. So let us see the small video, industrial video, how this galvanization is done in the industries. Here galvanization is done by hot dipping process. What is hot dipping process? You'll have molten zinc. In that, you're going to take iron or steel metal and dip it in that. That is called as hot dipping process. So I have again electroplating process, electroplating process, that is different. This is hot dipping process. These are iron articles. They just show part of it. Okay, huge iron stamps. So which usually will be used in functions in order to put pendle or such things. Okay. This is molten zinc. I think you can see the molten zinc, right? completely automated. You can see robots are used there. The iron rods are dipped there. You can see this robot will be lift that iron rods. This iron rods you can see it will be cleanly, zinc will be deposited very neatly. It is a beautiful structure. You have a lustrous surface, optical clarity, very nice. You can see how it is dipped. Very beautifully exported. You can never tell it is iron rods. You can see so beautifully exported, isn't it? This is how it is done in industries in the larger quantities. We'll see a smaller for screws, everything how it is done. If you have small nails, see these are nails which is one is galvanized, other one is non-galvanized. Just see how it is
Hot dip
done.
galvanizing is the process of metallurgically bonding zinc to steel to prevent corrosion. The challenge in galvanizing bolts is preventing zinc buildup in the threads, which can prevent nut assembly. Portland Bolt uses a specialized galvanizing process to ensure clean threads. Some bolts are blasted with steel shot to remove the excess forging, heat treat, or mill scale that can prevent the zinc from bonding properly with the steel. The bolts are then submerged in caustic soda, removing any cutting oil. They are then rinsed and submerged in sulfuric acid, which etches the steel so the zinc can penetrate the surface. The bolts are rinsed again, then submerged in flux to facilitate the bond between the zinc and the steel. The bolts are then transferred to baskets or racks and submerged in 840-degree molten zinc for 2 to 5 minutes, depending on their size and grade. The bolts are removed from the zinc and rapidly spun. Centrifugal force removes excess zinc from the threads. The bolts are cooled in water tanks, inspected, and packaged for shipment. Portland Bolt's specialized galvanizing line gives us control over the delivery schedule and ensures a trouble-free nut fit. For more information about hot dip galvanized fasteners, contact Portland
galvanized. So let us see anodizing. So what is anodizing? So depositing. So you know that aluminium and aluminium like metals have a special feature of they have got a boon. What is that boon? So you have aluminium. Aluminium undergoes corrosion, and whatever the oxide layer is formed, the corrosion product is formed. The corrosion product is non-porous, insoluble and stable. That corrosion product itself acts as a barrier between the surrounding environment and the metal, and it acts as a barrier and protects the metal from further undergoing corrosion. Okay, so therefore this aluminum like metals, that oxide layer itself will protect. So if that oxide layer is peeled off, again nature itself will develop an oxide layer and it will protect itself. That is a boon for aluminum like metals. So we are supposed to increase the thickness for industrial purpose. So increasing thickness of oxide layer on the aluminum and aluminum like metals by making the metal as anode in acid media is called as anodizing. So increasing the thickness of oxide layer on the surface of aluminum and aluminum like metals in acid media is called as anodizing. So anode is aluminum. So we're going to take some inert graphite, inert electrode as graphite as cathode. You're going to dip it in acid media, that is sulfuric acid or chromic acid media, and at around 40 volts at room temperature anodizing occurs. So depending on the application, you're going to vary the time. So if you want 0.1 mm thickness, we're going to vary the voltage, and we are going to vary the time duration. So depending upon the time duration, thickness also will vary. So if you want more thickness, you're going to conduct this process for a long duration of time. If it is a small thickness, then the duration of time will be less. So let us see a small video how this anodizing is done.
Hello science enthusiasts, you are watching a Captain Corrosion video about anodizing, and in this episode you will learn about the basic steps that are required to properly carry out this process. So let's cover them one by one. First, the aluminium substrate is mechanically treated by polishing or blasting with glass beads. This is important because it helps removing the poor quality natural oxide layer and most of the impurities that would hinder the formation of the anodic oxide layer. Then the metal substrate is cleaned from loose particles and minor impurities by rinsing with deionized water and organic solvents. In the next stages, the aluminium substrate is treated with warm sodium hydroxide and nitric acid in order to chemically remove the top layer of the metal, which results in a very clean surface and also exposes near-surface intermetallic particles. It should also be noted that the chemical treatment stages are sometimes not necessary if the mechanical treatment is already sufficient.
Mechanical treatments are using
Anyhow,
sandpaper and
the freshly treated metal is then anodized, where the anodizing parameters such as current, voltage, temperature, time and anodizing solution are selected based on final application. Finally, the pores in the anodic aluminium oxide layer are normally sealed to achieve long-term protection against corrosion, improve the resistance against mechanical damage, or to simply apply an aesthetic appearance. This can be done, for instance, by hydrothermal sealing, paints, or a variety of alternative methods, which will be discussed in the next episode.
This is how anodizing is done. Thank you.